Hi, welcome to the radioactive dating game measurement PhET simulation video. In this video, we are going to monitor the amount of two radioactive isotopes, carbon-14 and uranium-238, in two different objects, a tree and a rock. Now, to monitor the amount of the radioactive isotopes, we have this tool here. You see this tool kind of looks like a microphone, old style microphone. That is a Geiger counter. It measures radioactivity. The information from the Geiger counter is converted into percent of the radioactive isotopes. And you can see the percent over time using this plot here in yellow. So on the Y or vertical axis, you have your percent of your radioactive isotope. On the X axis, the horizontal axis, you have your time in years. You can also measure the amount of radioactive isotope using this white box that's above where it says probe type. That'll show you the percent of your radioactive isotope, so your percent of carbon-14 or percent of uranium-238. And the box underneath the yellow plot will tell you your time in years. So you can use either the plot itself or these two white boxes. Now we're going to start by measuring the amount of carbon-14 in a tree. So we're going to begin by planting the tree. When I click on plant the tree, I want you to make sure that you closely follow the percent of carbon-14 that we have in the tree. But before we go into the simulation, remember you're answering these questions with the simulation. So for this first part of the simulation, where I measure the amount of carbon-14 in the tree, we're going to be answering these three questions. Take a moment to read those. And then for question 3, where it says, let's see how scientists use that information, there are two data questions. So there's the first one, 3A, and the second one, 3B. Okay, so now that you have a sense of what you'll be doing during the simulation, you're monitoring the amount of radioactive decay and over time, and then using that to, radioactive isotope, and then using that to answer these questions. Let's go ahead and get started. So remember, I'm going to plant the tree. So it's tree selected. I'm looking at carbon-14, that's selected. I'm planting the tree. Keep a close eye on the percent. Take a look at the percent here. Now, trees don't live forever, so eventually this tree dies. Take a look at the percent now when the tree has died. What's happening to the amount of carbon-14 over time after the tree has died? Okay, so this simulation takes a long while to sort of run out, but you're noticing what's happening to the percent of carbon-14. If you look at the box here, or if you look at this line, you'll notice this line is going down. So what does that tell you about the amount of carbon-14 in the tree over time? What I'm going to do is I'm going to pause this, and then at the very end, I'll return to show you how long it takes to get to 0%. I am back. I'm going to just want to give you an update on where we're at in the simulation. So we're about 20% of carbon-14 left in this decaying tree here. Take a look at the amount of time that it has taken to get to that point. Do you think this is a long amount of time or a short amount of time to get to that point, to get to about 20% of carbon-14 remaining? All right, I'm going to pause it one more time, and when we return, you can see how long it takes to get to 0%. Actually, before I pause it, take a look at the rate of decay. See how the numbers are changing. Are they changing as fast as they were at the beginning of the simulation? you need to, you might want to rewind back. Take a look at that. Okay, I'm going to go ahead and pause the video, and then when we come back, we'll be at 0%. You'll see how long it takes for that. Okay, we are nearing the end here, so let's take a look and see how much we have right now. We have 0.1% of carbon-14 remaining in this decaying tree. Take a look at the amount of time that is taken. I should note that this amount of time is the amount of time since the tree was planted, so not right when the tree died. And this has taken so much time that the graph is sort of off the charts there. So we don't even see the graph moving anymore, but we can monitor the percent of carbon-14 here. As soon as it hits 0, I will press pause. Oh, here we go. Okay, so this is as long as it's taken for all of the carbon-14 isotopes to decay in the tree. Again, do you think does this take a long amount of time or a short amount of time? So after thinking about that, you're going to come back to, you're going to come back to your questions here. You have these 3 questions to answer, and also don't forget the ones in the table. All right, in the next simulation, after you're done answering the questions, we're going to monitor uranium-238 in the tree. Have a quality day.